Okay, so we've done hypothesis testing for means. Now let's look at the hypothesis test for proportions. And remember, when you're finding the hypothesis test for means, you're going to be talking about averages, the mean. You'll hear those wordings. When we're talking about proportions, we're talking more a certain number out of the total. So fractions, decimals, percents. That's what you're looking at when you're looking at proportions. Now, our conditions, we need a simple random sample. And n times the proportion, and n times 1 minus that proportion should be at least 10. That second condition is our sample size requirement. Now, our sample statistic is this p hat. That's the sample proportion. The p sub 0 that we're going to use to test our sample size is going to be our null value. Now, if we were going to calculate the z-score by hand, we'd find the difference between the sample proportion and our null proportion divided by the standard deviation. You should recognize that as our standard deviation. So, an educational specialist is studying attitudes of teachers about the use of virtual reality in the classroom. She samples 500 teachers and finds that 471 of them believe that virtual reality would have a positive effect. So I know that my n is 500 and my x, the number of people out of the sample, is 471. Can she conclude that the proportions of teachers who believe it will have a positive effect is greater than 90%? So her claim is that the true proportion is greater than 90%. So my null hypothesis is that it is 90%. Now let's verify our conditions. Do we have a random sample? Well, we're going to assume so, since they didn't say it. Did they tell us it was normal, or is our sample size large enough? So to check our sample size, we're going to be using the null value. So 500 times 0.90, and then n times 1 minus p naught. So 500 times 0.10, 1 minus that. It would be helpful to have my calculator handy. So 500 times 0.9 is 450. Check. And then 500 times 0.1 is 50. Check. Okay. Now I'm going to show how to find that test statistic by hand. It says we're going to take our sample proportion minus the null divided by the standard deviation, which is going to be the null proportion times 1 minus the null proportion divided by n. Now I need that sample proportion. My sample proportion comes from the sample, and that's 471 divided by 500. So 471 divided by 500 minus 0.9. Whoops, I forgot you have to say answer, minus 0.9. Okay, divided by the square root of 0.9 times 0.1 divided by n, which is 500. And I get 3.13, which is pretty big for a z-score. Wow. Okay, so the next thing we want to do is calculate our p-value. Well, I'm going to go to inference, test, and we're dealing with one proportion. So test, one proportion. I better flip back over to get all my information. Okay. One proportion. My null hypothesis was 0.9, 90%. And she was talking about it being greater, so greater is fine. Number of successes. That's the number of people in the sample who agreed. So 471. Sample size, well, it happens to be 500, okay. Significance level, 0.05, okay. Next. Test statistic, 3.13. Hey, that's what we got. And it gives me this p-value that's kind of interesting. The p-value is 8.725593 E negative 4. That E negative 4 means times 10 to the negative 4. So this is really 8.72 times 10 to the negative 4. That would be 0.000872. Well, if I compare that to my alpha, so this is P, my alpha was 0.05. This is super, super smaller. And if the p-value is smaller, then the null can be rejected. Now, if I reject the null, then we can conclude that the proportion of teachers is greater than 90%. The proportion of teachers is greater than 90%. There are two major college entrance exams that a majority of colleges accept for admissions, SAT and ACT. ACT looked at historical records and established 22 as the minimum score on the ACT math portion to be considered prepared for college mathematics. Being prepared means that there is a 75% probability of being successful in college algebra. An official with the Illinois State Department of Education wonders whether less than half of the students will be prepared. She obtains a simple random sample of 500 students, and 219 of those are prepared. Does this represent significant evidence that less than half of the students in the state of Illinois are prepared for college math upon entrance to high school? Okay, so, and from high school. So the Department of Education was speculating that the probability is less than half. So my null hypothesis is that it is half. Now they did tell me this was a random sample, yay. And now I need to check n times my null and then n times 1 minus the null. Well, that's going to be easy, half and half. 500 times 0.5, 500 times 0.5. That's good, that's good. Let's back up. My null is 0.5, and we want to see if the proportion is less than that. And there was 219 out of 500, 0.05 level of significance. The test statistic is a z-score. It's negative 2.772. And the p-value is 0.002. That is definitely less than my alpha. Alpha was 0.05. P is less than alpha. We reject the null. There is evidence, or we conclude is sufficient evidence that less than half are prepared. The drug Prevnar is a vaccine meant to prevent meningitis. It is typically administered to infants. In clinical trials, the vaccine was administered to 710, N is 710, randomly sampled infants. Of those, 121 experienced a loss of appetite. Is there significant evidence to conclude that the proportion of infants who received Prevnar and experienced a loss of appetite is different than 0.135? And that's the proportion who experience loss of appetite with competing medications. So their claim is that the proportion is different than 0.135. So my null is going to be that it is 0.135. Random sample. Is this going to be large enough? 710 times 0.135. Yeah. So let's go back. The null is that it's 0.135. Our alternative is that it's not. And we had 121 out of 710. And this one says we're doing alpha at 0.01. So my z-score is 2.762. The p-value is 0.00574. Alpha was 0.01. That is less than alpha. So we reject the null. The proportion who lose their appetite is different. Whoops, I'm sorry, than 0.135. All right. Time magazine reported that in a 1994 survey of 507 adults, 59% answered yes to the question, do you favor allowing women to be priests? So my sample statistic is 0.59. Test the hypothesis that more than 55% said yes. Okay. So the claim that we're testing is that the probability is more than 55% or 0.55. So my null is that it is 0.55. Now, this one is set up a little differently because they gave me my sample proportion, but they did not give me my X, my number, and I need that for my calculation. Well, that's just going to be 0.59 times 507. So we're testing 0.55, 55%. And the claim is that it's greater than that. The number of successes, 0.59 times 507. See, I can do that right here in the screen, so I don't have to go anywhere else. Out of 507, and we're doing it at 0.05. Test statistic. Oh, we have a random sample. Yes, 507 is definitely large enough. Z is 1.799, and the p-value is 0.036. Alpha is 0.05. P is less than alpha, so we reject the null. The proportion is greater than 55%. So notice that we're going through the same process. It's just what we put into the calculator is going to be a little bit different. Now, I'm going to go ahead and talk about this. Determining which type to use. And it says we did 3 in the textbook. They did 3. We're doing 2. So we're either going to be testing about a mean or about a proportion. And so we're always testing the population mean and the population proportion. That's what we're testing. And you're going to see words like average and mean. And here you're going to see things like percent. And we're going to have so many out of so many. You're going to have these decimals when they're dealing with percents. And then there's a nice chart about which test you're going to use when you're doing the means. So remember that n has to be greater than 30. Now, if we know the population standard deviation and n is greater than 30, we're going to use the z method, the z-test. If it's not greater than 30, then we want to check to see if the population is normal. So we can use the z-test. If the population is not normal, consult a statistician. If we don't know the population standard deviation and our n is greater than 30, we're going to use the t-test, t-method. If it's less than 30 and the population is approximately normal, we can still use the t-test. So this is a good chart for remembering which test we're going to use.